Hey guys, SHIFT838 here. I want to take a minute to show you my latest project I've been working on, which was, or is, converting the original IDE card for the TI-994A in Geneve to through-hole components. I've added a couple of extra features. I just wanted to go over and show them to you real quick and show you what I've done. So what you see in front of you is the prototype, 100% through-hole components. It is compatible with the 5-volt modules, real-time clock modules of the BQ4847, which is one of the original clocks that the original car was designed for. It's also compatible with my 838 real-time clock module, which utilizes the BQ4802 5-volt version. So what I've done to this card to try to make it a little better, a little bit more I don't want to say user-friendly, it's all user-friendly, but a little bit more compatible with other devices. So on top of your standard 40-pin IDE adapter, which you see on the back side back here, I've also added a 44-pin IDE, which actually provides power directly to it. So if you have a 44-pin IDE module like I have here, then you don't have to provide power. It's already done through the connector. Now, one thing to remember between these two connectors is you got to choose one or the other. You can't use both of them. So you can either use the 44 pin or the 40 pin, but not both at the same time. You can use primary and slave on each connector. So you could have a primary and slave on the 40 pin or primary and slave on the 44 pin. Another thing I've added is I've got power breakouts here that put a 2-pin header, 5-volt and ground, and then I've got an actual Molex connector here. This is the same Molex connector that's actually mounted on 3.5 drives or IDE hard drives. I do sell a cable with this that actually has the female version on both ends of a cable. So if you're using like an IDE to CF adapter, you can plug it directly in. And this is what the cable actually looks like. So as you can see, just 3.5 on both ends. And it just plugs directly into here. And then you can plug it into your CF card, or your IDE to CF card, IDE to SD card, whatever it is. I have tested with both IDE to CF, single CF, and dual CF card, as well as an IDE to SD card. Now this will give you partitions of around 260 megabytes per partition. You can have 4 partitions per device. So if you have a dual CF card, you'll have IDE 1 through 4 on one CF card and IDE 5 through 8 on the other. And of course, your CF card would be primary and slave. Now, this is my 838 real-time clock module. Has the battery backup already on there, as you can see. So when the battery runs out, you can just swap it with another CR2032, reload the DSR, and you're ready to go. This one's already set up for the Geneve. Later in this video, I will be demonstrating it working in the Geneve as well as in my TI system. So the other thing that I did with some help from a few people from Atari Age, and this was being discussed originally to replace things on the Myarc Geneve 9640 to make it run cooler. And I kind of ran with that and asked a few questions and got a few answers, and I was able to implement on this card. So instead of it using a standard 7805 voltage regulator, I'm using a DC to DC converter right here. And it's a 7805, it's pin compatible. The only bad thing about it is you can't screw it down, but it doesn't require a heat sink. It's not going to go anywhere. It's pretty solid. The good thing about this DC to DC converter is with my initial test with a 1.5 amp 7805, I was pushing 130 degrees Fahrenheit constantly, between 130 and 135 constantly. With this installed, I get between 80 to 85 degrees Fahrenheit. So it's a lot cooler, about 50 degrees cooler. So I'm happy with that. They're a little bit more expensive, but I'm happy with it. Everything is socketed on the card. You got your CRU here, which it changes. Now this card is designed to use Fred Cow's DSR. His latest version is 15, which I actually have loaded on here. With that DSR, you can actually emulate DSK1. So you have a directory or folder, if you will, on your storage media called DSK1. And if it's enabled, and if the CRU is set to be before the floppy disk controller, then it will scan the IDE card inside the DSK1 first, so inside the DSK1 folder. And if it doesn't find it, then it goes over to the regular floppy disk controller, if you have one. Some people won't have one. But this is the card. It's real easy to use. It's all socketed. Pre-orders are up on my site. If you get there and the pre-order's already closed, shoot me an email. I may have some extra. This one here is the prototype. Has one correction on there that I messed up and forgot to. Somehow I was I mistyped a net name, and I got no voltage to my real-time clock. So I actually have a wire that runs to a 5-volt source on the back of the card just for the clock. Otherwise, it'd just run on battery all the time, and it would drain your battery quicker. But that's been fixed in the production version. So that's the intro to the card. I will throw up videos attached to this video. You'll be able to skip forward for the TI and Geneve where it's actually working. Hey guys, for everyone that stuck around to watch it work, this is the Geneve. I actually have it installed in the Geneve. I'm booting it up. It will take about a minute, 30 seconds, about 30 seconds to a minute to time out on the HFDC before it tries to boot on the IDE. What I have in my system is a Geneve with a 384K mod of mine, which also on the Geneve has the latest 2.0 boot EEPROM, which is required to boot from TIPI or IDE. I have the IDE prototype in here. As you see, it's booting. I also have a TIPI in here, and like I said, a HFDC. My drives on the HFDC are turned off. That's why it showed the load-IDE boot, because it pulled it up. So as you see that I've got the TIPI installed, and it checked, said it no update available. That's great. So I also showed the drives that I have right here. I actually have that in auto execute file, just displays. That way, anyone that orders a CF card or something with, for the Geneve, I can put that on there, and that way they know. This does run version 7.42 MDOS development version. It does have fixes in there to get the IDE card to function correctly. So let's go ahead and get into what I've done. So with MDOS has limited amount of space left for memory and registers and everything. So they created what they call a SCSI map. And this will let me remap SCSI devices to be used for IDEs. Okay, so this SCSI 1 really means, kind of like IDE 1, 2, all the way through 6. You can only access 6 out of 8 of the IDE drives at one, within MDOS. IDA, that's really the partition. So this would be IDE 1 is mapped to partition A. IDE 2, partition B. or partition 2 is the way it would be. So that's the way it runs. So as you see, I have, my SCSI already set up for, SCSI 1 is going to be IDE1 partition 1, right? Then if I go into my assign command, which I did all this in my auto execute file, my E is SCSI 1. Well, I've remapped my IDE to respond as SCSI 1. So this is what my IDE is going to be. My IDE 2 is going to be F drive and 3 G drive. 4 is H drive, then my TIPI is I, right? So just to show you, here's my TIPI. And that's if I wanted to load from TIPI, then I can disable the IDE card or not have system-sys on it, and it'll fail over and load on TIPI. Said this is my IDE 1. So say SCSI 1, partition 1, said it's really IDE. That's my auto execute file. Throws it in TI mode, got my standard path, my prompt. These are my SCSI map that I just discussed, and my assign, what it's assigning. Make sure I go back to the E drive, then it echoes everything. This tstat here is a great little utility that was released for MDOS to be able to check your TIPI status for an update through MDOS. So you don't have to go into the TI mode and work through all those hoops to get it updated. Go into GD. So this is DM2K for Geneve. This is all coming off the IDE 1. Okay, so E. We'll take this to okay, there's nothing there, right? So we're going to come over here and we'll just copy GDM2K. And of course, it's fairly quick going from partition to partition. And it's done. It's going to reread. Inside the directory, they're all there. So, and that's it for the Geneve. So I have test copied over 140 megabytes of files from one partition to another, from the TIPI to one of the IDE partitions, and everything works great. But that's it for the Geneve. Hey guys. So this is the demonstration for the IDE v3 version 3 on the TI. And this is actually on my test bench system, which actually is on a test bench. So let me show you. The card is actually already installed right there. You see it's an open design. This is just a test system. This is not an actual TI PEB backplane card, or whatever they want to call it. This is one of my own design. So let's show you that it's already set up for the TI. It has the same, it's the same exact card that was in the Geneve a minute ago, that if you watch that video. It has the same Transcend 4 GB memory module that acts as a hard disk drive. So show you things are working. Let's show you the DSR. I'm going to show you the clock's working. And let's see what time it is. Alexa, what time is it?
It's 4:50 p.m.
So it's 4:50 p.m. on November 15th, 2023. Call IDETD for time day. There it is, 4:50, November 15th. We'll do a IDEst for status. This will show you that I have IDEs 1 through 4, 5 through 8, not there because it doesn't detect a slave device. Shows you the clock chip being used is the BQ4802, which is the 838 real-time clock module. That's the clock chip that's installed on top of that. Battery level is good, and DSK1 emulation is enabled. So we know it's there. So let's go ahead and go into DM2K, which is J for 3.0. Go to IDE4, which is where we're going to copy. And show you there's nothing there. Volume name's P4. And we're going to copy some stuff from the Tippy. DSK0 for Tippy. So we'll do, I don't want to do that entire Infocom directory. If I did that, I would have to speed up the video because you'd be here 15 or 20 minutes. So let's just go inside the Infocom directory and we'll just copy, I don't know what's in one, but let's do a number 3. I don't know what's in there. I haven't played these in a while. Take it to IDE4. Oh, it's Plundered Heart. Okay. So as you can see, it's clicking up here and what it's reading. It goes up by sector count, 32, 64, it increases by 32. If it's under 32, it just shows 0. At least that's the way I believe it's working. And it's almost done. As you can see, it can copy fairly large files. It's not a problem. I've copied, I think, 140 megabytes, at one time. And it just cycles through it and goes it just like any regular file manager. So we'll go ahead and exit out of here. Do the cal directory. Got to remember to hit C. As you see, it functions just fine. I've been running this card for over 3 weeks now, every day, and it seems to be rock solid. I don't have a problem in the TI or the Geneve. I have a prototype strictly for the TI. It's the same exact card, but I wanted to show on this video that I was using the same card that I used inside the Geneve. So you can move them back and forth, as long as you remember to change the settings or the switches. You have 2 switches on the card that enable TI or Geneve, or you can turn it off. So we'll go to IDE4, and there they are. If I want to run disk utilities, DU2K, execute. There we are. So it works. Thanks for watching. Pre-order is up. If you get there, the pre-order is not up, or I'm out of stock, shoot me an email if you're wanting one and let me know. If I have some laying around, some more boards I just haven't built, I'll let you know. Otherwise, if I have to make another run, a small run of them, that's not a problem. Thanks for watching.